Okay, hello everyone. Hope you're doing well. My name is Marcus Benson. For those of you who don't know me, I'm a docent in medical informatics. I work as a senior lecturer at Linköping University, and I do a lot of research on interventions, behavioral interventions, mostly, well, almost exclusively digital nowadays. And I also like to look at the methods that we use to evaluate interventions. So I care greatly about how we do effectiveness evaluations, so randomized controlled trials, for instance. This talk is not one of my usual talks. So I'm schooled in the technical school where you set up a problem and then you carefully dissect it and find solutions to all the small parts, and then you prove something and you show that this is our ultimate solution. This is not one of those talks. So in normal cases, I could just lock the doors and not make people leave. I can't do that here. But basically, this talk is about provoking attention to something that I think is overlooked in the literature quite a fair bit. There's going to be parts in here that you've heard before, maybe parts that are new, but I think there'll be something in here for everybody. But don't expect to go from this talk sort of enlightened. You might be more confused than when you joined, but I think that's a good thing. You should be confused when you do research, otherwise you're doing it wrong. So really, this is just about provoking attention to several topics, which I think are understudied. I actually didn't say what this talk was about. Let me go back. My talk is about research participation effects and other biases revisited. It's mainly going to be about research participation effects, but I want to show you a couple of biases and not just sort of mentioning them, but actually quantifying them. And these are things that I've stumbled upon last year that I think are important to look at. Okay, so what is bias? Well, there are several definitions. I like to think of it as their effects which are caused by academic and research activities. And I separate academia and research because academia is in some cases broken while science and research continues on. But I think bias is caused by academic activities and research activities, which may mislead scientific discovery in a way. And it creeps up everywhere. It creeps up in when we do measurements, when we design studies, when we execute studies, when we analyze studies, when we report studies and publishing and synthesis. It creeps up everywhere. So I think the attention to bias needs to be in the forefront. I usually think of study design as something that is super easy, but it's a series of making bad choices, and you have to choose the least bad one. A randomized controlled trial on paper is very simple, but you have to then, when you execute one, make a series of decisions. All of them are bad, because they might introduce bias. You just have to pick the least bad ones. So bias really is introduced everywhere in our research process. There's this fantastic website driven by the University of Oxford called the Catalogue of Bias. They list a whole bunch of different biases. You can go in and read on each one of them. It's almost like a dictionary or a catalog, and you can see what evidence there is for these different biases. They have this little paragraph, which I've copied, which says, to obtain the least biased information, researchers must acknowledge the potential presence of biases and take steps to avoid and minimize their effects. Equally, in assessing the results of studies, we must be aware of the different type of biases, their potential impact, and how this affects interpretation and use of evidence in healthcare decision-making. So I'd say this, I think they could just remove healthcare and put scientific process, because bias can be introduced not only in healthcare. But what I react mostly at is these two words, avoid and minimize. So I'm a little bit surprised that they don't have accounting for them. Why do we only have to avoid them and try to minimize their effect? Why can't we actually include them in our analysis and account for them? So that is going to be my later part of this presentation or talk, is going to be about, can we actually account for them if we know what their magnitude are? So I think this definition is good, but there's something missing. In the consort checklist, which many of us use to report our trials, there are many points. I can't remember how many checkpoints there are, but what strikes me is that in the part that has to do with analysis, they mention that you should report your primary and secondary outcome, results for each group, estimated effect sizes. You should include subgroup analyses, adjusted analyses. But addressing sources of potential bias ends up in the discussion. So it's something that you need to address in your limitations. It's something you need to mention as a limitation of your study. And I think it's strange, considering that bias has such a massive impact on science. You would expect that it should have a higher priority than just end up in the limitation section and discussion paper. I would expect it to be accounted for in the analysis. It's not enough just to mention them. Anybody can say, well, these were my limitations, but what did you do about it? I think there's lacking this analysis step where how do we take care of bias? And we'll get to that. And finally, another one which is commonly used. So Cochrane risk of bias tool, which is supported by Cochrane, and many use this to estimate bias when they are doing meta-analyses. This is a tool you can use to sort of gauge how high the risk of bias is in a randomized control trial. And it actually says that the domains of this ROB2 tool covers all types of bias that are currently understood to affect the results of randomized trials. And then they say bias arising from the randomization process, bias due to deviations from intended interventions, bias due to missing outcome data, bias in measurement in the outcome, bias in selection of reported results. I find it curious that none of these are pre-randomization. They only mention stuff that happens after randomization as currently understood to affect results. And I disagree. And that's what my talk is going to be about, that we have stuff that goes on pre-randomization that actually could also introduce bias that we need to take care of. Randomization doesn't solve all our bias issues. Right. Before I get to research participation effects, I did promise to talk a little bit about bias in general. So here are three striking examples of how bias may shape science. And you know, those who know me know my anger. And I mean, hatred is a strong word, but I think hate is too weak a word for what I think about p-values and evidence dichotomization. So I'm going to take this, every time I give a talk, I need to sort of push against this praxis. So I'm going to show you three examples of issues in science and how bias has shaped science. These are two studies done by Sweet, Cater, Barnett, and Wren. And Sweet and Cater basically based this on Barnett and Wren's work. And what they did was, and I find it hard to believe that it took until 2020 to actually do this, but what they did was they gathered 968,000 confidence intervals and 350,000 intervals on top of that from full text papers published in Medline through PubMed from 1976 to 2019. And then they converted those to Z values. And you can think of Z values as if it's greater than 2 or less than -2, then we have this typical statistical significance. That means that your results are statistically significant in the p-value world. So I'm going to show you a picture now, and you're not going to be able to unsee it. So it's going to change your life, and I should perhaps sort of collect informed consent before I show this image, but just be aware that look away if you don't want your life changed. What do you think the distribution of these were? Well, something like this. This is publication bias in its purest form. There's a lot of stuff here that was sort of not significant and was never published. So here we see all of these fine, nice, significant results. And then as soon as you hit 0.05, nothing gets published. And then when you have the other side, stuff gets published again. This is sort of shocking. Like there's a whole bunch of science and research going on that we know nothing about that was never published here. Because this should, I mean, be more or less normally distributed. So there's like a black hole here of science missing. And for me, this really questions the value of systematic reviews and meta-analyses, because meta-analyses are usually just produced based on what is in the literature. And the literature is obviously super, super biased. And I blame this on the effect of academia, our strong belief in publishing significant results, or what we call significant, and also this urge to dichotomize, which seems super weird. This stuff, my wife is terrified of snakes, and when she sees snakes, she jumps away from her phone and she gets all sweaty. I get all sweaty and worried when I see this. This is shocking. And looking back at Ronald Fisher from circa 1926, he said, personally, the writer prefers to set a low standard of significance at the 5% point and ignore entirely all results which fail to reach this level. And he got his way, I guess. I mean, 100 years later, we still do this. So he wanted Ronald Fisher, if he truly wanted this, he got his way. Okay. What else? Well, there's an excess of positive results. So there's a lot of positive results and not a lot of negative results. So Sheen and Lakens looked at comparing reports of experiments which were pre-registered versus experiments that were not pre-registered. So we are, at least I am, grown up with the thought that all your experiments need to be pre-registered and you register it and you publish a protocol. That has not always been the case. And in some disciplines, you still don't do that. And what they found was that 44% of first hypotheses were supported in registered reports, but 96% of first hypotheses were supported in standard reports. So the basic message is, if somebody says, here's a nice report I made, I have a significant value, my hypothesis holds, and they never pre-registered it, don't trust it, basically. I mean, the value of registering your protocol, registering your hypotheses is clear here, because this is just sort of data dredging and p-value hacking bias. You figure out what's significant and then you publish that and not the rest. And this doesn't help the previous image with the big black hole in it, right? It just adds to the problems when you publish more and more significant results that have just been by chance significant. Okay, and then my last example of how bias, and this really doesn't have anything to p-values. My last observation here is this study, which is quite old now, but is interesting. They looked at observer bias in randomized clinical trials with binary outcomes. So in these 21 trials that were included in this systematic review, they'd done both blinded and non-blinded assessment. So the person actually assessing the patient was blinded and non-blinded, and they compared. And what they found was that odds ratios were exaggerated by 36% when the measurement was based on non-blinded assessment. So when the assessor was not blinded, when they knew about which allocation the patient had, odds ratios were exaggerated by 36%. You don't really have to understand or see this image, but you can see for every study included in the systematic review, there's an empty box and a filled box. The empty box shows the non-blinded ones, and you can see all the non-blinded assessments are very exaggerated. So even though it's very subtle, and maybe this person who is asking the patient about how they feel or function, they don't want to bias results, and they may be aware of the problem, but still it creeps in. So blinding of both research personnel and participants is very important, especially when we do assessment, because it might creep in and exaggerate results. Should be said here that there was actually a high rate of agreement between the blinded and non-blinded outcome assessors, but the bias was mainly driven by misclassification of a few patients. Okay, these are three examples which I caught my eye last year, and I wanted to share with them, again, just to provoke attention. Just remember these things when we're doing science, because we get all caught up in writing grant applications and doing our studies. We sometimes forget to see the bigger picture. And I think this is important to just remember what we're doing and what we're dealing with. But now to the sort of core of what I want to talk about. And it's about decisions prior to randomization. So decisions we make when we design studies that are prior to randomization, and opportunities to account for biases formally in analysis. These two things I've spent some time on. I'd like to share what I've found. But again, it's not going to give you a clear answer. It's about provoking attention to this. These are the Hawthorne works, the Western Electronic Company in Illinois. Famous, surely for what they produced, but also for the Hawthorne and the studies done there, the Hawthorne Effect. So in somewhere with 2030s, there was experiments done at this factory where they were looking at changes in work environment and seeing how that affected productivity. And what they mainly were looking at was different lighting levels and seeing if that changed productivity. And what they found was that any change any change of lighting or any change of environment increased productivity. And that was basically their conclusion. Then that was debated and discussed, and Landsberg in 1958 suggested that we should call this the Hawthorne effect. And he suggested that, well, the change you were seeing had nothing to do with the environment. It just had to do with the fact that you were paying interest to these people. You were studying them, and therefore they changed. So it actually had nothing to do with the experiment you wanted to do. And this has been then given the Hawthorne effect. And this was discussed and debated for many years of why does this happen? Does it have to do with, well, the people knew what you were expecting. You were studying increased productivity, and therefore they increased the productivity, or was it because you were paying them interest? And it was debated why this Hawthorne effect sort of emerged. And there was a systematic review published in 2014, which basically established that there isn't a single Hawthorne effect, because when people talk about the Hawthorne effect in the literature, they mean different things. So it's been operationalized and used differently. And as a concept, it's not very useful. I can't remember actually how many papers were in this systematic review, but there were many. And basically none of them seemed to agree what the Hawthorne effect was. So it was decided in this paper and a later one that there was a need for a more fine-grained concept of research participation effects. So this research participation effects construct was suggested and then studied. So this is basically the idea. We should put ourselves in the shoes of a potential participant and slowly and carefully think about how the things we make them do affects them. How does contacting people affect them? So if you're in a waiting room and then somebody comes up and says, we're doing a study on 65-year-olds and older, would you like to participate? How does that make you feel? Well, one, you obviously realize I look 65 years and older, so that's maybe going to change your perception a bit. Or if there's a study about obesity and somebody approaches you and says, would you like to participate in this study about obesity? How does that affect you? Already there's an interpersonal contact, and the person you're approaching has already started a process in their head. And I'm mainly thinking about behavioral interventions now because it's sort of obvious that we can affect that, but it might also happen in other sort of non-behavioral trials as well. So initial contact and how that affects your participants is something that should be borne in mind. When checking for eligibility, suddenly you realize you're eligible for a trial which is supposed to support risky drinkers. You didn't actually think you drank that much. Turns out that you do, and now you're eligible for a trial that's supposed to help people reduce their drinking. How does that affect you? How does it affect you that you're giving study information that you're supposed to read and read through that study information and sign the consent form? How does that affect you? How does baseline assessment then affect you when you start answering questions about your health? And how does randomization affect you? The fact that you cannot choose what you want, but you're actually going to be randomized to a treatment, and you might have preferences. How does it affect you knowing that you're in the control group? How does it affect you knowing that you're in the intervention group? And how does follow-up assessment affect you? And the biases that might be included in all these pieces. So what the Hawthorne effect failed to do really was that it was a general concept that tried to bunch all of this into one. And this research participation effects concept is trying to split this up so we can study them in more detail. And I have to say, this is super understudied. We know very, very little about this. And we also know very little about which people are more susceptible to these kind of biases and not. And we could go through sort of, I think a big research program is needed to figure this out so that we can learn more about these biases. But I'll show you some insights into what we know at least. And there's more in the literature, but I'll show you some interesting papers. Okay. Why would you want to participate in a study? This is a question I've asked myself a lot of times. So we do a lot of, I'm part of a research group in Uppsala, and we do a lot of survey stuff on university students. And we go into Qualtrics, we set up a survey, we hit send, and it takes literally seconds, and people start responding to the survey. And I'm shocked every time. Why? What is it that makes people want to participate in research? This is a nice paper that looked at reasons for participating in a large randomized controlled trial. This was minimal access surgery versus continued medication. They did qualitative interviews with 13 potential participants. And among the ones that actually accepted participation, they said that, well, initially, I felt like I wanted to help others. There were quotes like, well, if everybody said no, then science can't proceed. So we need to help each other out. But all of it came down also to, well, and then what was in it for me? So there wasn't, altruism wasn't enough, but also what is in it for me? And once participants start thinking about what's in it for me, then they start having expectations. And what we do to them throughout the trial is going to be affected by those expectations. Among the ones who declined, they basically said that they thought that the negative consequences for themselves was too great. So while they were interested from an altruistic perspective, the negative consequences that they perceived was greater than their belief in the altruism. There was only 2 that actually declined and said this, but both said this, and they said it because they were quite happy with their medication and the way things were going on medication, so they didn't want to have surgery. Yet they did still fit the eligibility criteria, which then biases the generalization of results here. So this conditional altruism, I think, really captures well why people want to take part in studies. Yes, there's part of it that they want to help research. They believe in the research community. They believe in research being for the greater good, but they want something from it themselves as well. What's in it for me? I don't have time to talk about this paper, but this is a great paper. It's called "It Was a Snap Decision: Parental and Professional Perspectives on the Speed of Decisions About Participation in Perinatal Randomized Controlled Trial." Super interesting results from the parents and the professionals' view about how the reasoning went in a quite stressed environment of taking part in the trial or not. Worth reading if you're interested. And I think that's a very nicely way of studying this phenomenon. Okay. We understand that people have expectations when they come to a trial. They might want to participate in a study because they want to help science, but they're also thinking about what's in it for me. I think smoking is a nice example of a type of behavior which I'm just guessing now. A lot of smokers don't want to smoke, but they continue smoking. They want help to quit, but they just continue smoking because it seems difficult. A lot of smokers have tried to quit and failed many, many times. And so if they walk past a poster where it says, "Do you want to quit smoking? Help us evaluate a 12-week novel mobile phone-based smoking cessation intervention designed for university students." So you're a university student, you smoke, you've tried quitting several times, and you see this poster and you go, well, that's interesting. Maybe that's something new that will help me this time. I've tried so many times before and failed. Maybe this will help me. Your conditional altruism is somewhere in the line of going, well, it's good for research, but it's probably going to be good for me as well, because I might get access to this nice and novel intervention that has been designed. And this is quite common. I see this all the time. I honestly do it myself. This is how we advertise our trials. We talk about the intervention, but really the other side is also there. Why don't we ever advertise this? Do you want to quit smoking? Help us evaluate treatment as usual. Because that's the control condition most of the time, the treatment as usual. So why don't we advertise that side? And what kind of bias does it imply that we advertise the intervention side, but not the control side? Because my conditional altruism is going to be very different if I see the first one versus the second one. My expectations of what this trial is about and what's in it for me is going to be very different. And maybe even worse, what if it said something like this? Help us evaluate waiting for 12 weeks until you get access to a novel intervention. So actually advertising the waiting list condition. Ethics does sort of rely on the fact that we believe that both conditions in a randomized controlled trials are equally good or equally bad. That's why we're doing the trial. We don't know. But we do still bias our studies by promoting the intervention side. This should be studied. I'm going to set up a study to see if anybody would ever sign up for one of these posters. Help us evaluate treatment as usual, or help us evaluate waiting 12 weeks. Having said that, I remember speaking to a PhD student in Denmark, and she said she was working on a project where they were trying to digitalize a personal communication with a substance use disorder program. And the way it usually worked was that you came to the clinic and talked about substance abuse, and that was loaded with stigma, etc. So they were trying to do it via a digital link. And people got randomized, and then somebody in the study, they were asking the participants, well, what did you think about the study? And they said, well, you know, I got this video call and I was unlucky that I didn't get to get this personal sort of contact and actually physical meeting. So what we perceive as the positive side of what we are promoting as novel and new might not be for the participants. They might actually prefer the control side. Anyway, what's in it for me is very much shaped by initial contact and reasons for joining the conditional altruism. And then I would say something that is then a condition or sort of caused, or issues that it can be affected, are the reaction to allocation. So if I've seen this poster number one and I've got this idea of what's in it for me, and then I end up in the control group, then I might be full of resentment. I might be demotivated, like, oh my God, here was this was my final chance to quit smoking, this new technique. I've tried everything, and now they tell me that I'm not going to get it anyway. And how does that affect participants, and how does that affect the follow-up measure? And also, we've seen in qualitative work that participants might just decide not to change their behavior, just to go, oh, well, you know, I didn't get access to the novel intervention, so I just continued smoking anyway. And how does that then affect our contrasts later on? This part about the waiting list, I could talk about forever, and it's something I could say a lot more about. That will be at a later date, but there have been studies of how a waiting list control affects behavior. And there's an upcoming study that we're planning for now to inspect this further, because there seems to be quite a lot going on there, despite the fact that waiting list control is sort of considered ethically more defensible than a no intervention group. And this needs to be studied further, because there are plenty of waiting list control designs going on out there, and the effects of that we don't really know. What is the effect of the participants in the waiting list group? That's another talk for another day. Right, so you've gone through you're a participant in my study. You've gone through the part of deciding that you want to be in the study. You've seen the information, the advert. You've decided what's in it for me. I have my expectations set up, and now we're going to ask you to sign informed consent. So does the fact of just signing informed consent change your behavior? Does it bias the results? Does something happen to you when you read information sheets and sign informed consent? This study was a study done among university students. University students were asked to take part in a health survey. So they were just asked, would you like to take part in a health survey? There was some screening about alcohol consumption, if I remember. And then the intervention group, well, everybody that was part of the study got a sealed envelope, and the intervention group in the sealed envelope got an information sheet, an informed consent form, and an audit questionnaire. So the audit questionnaire measures alcohol consumption. The control group just got the audit questionnaire, so they never got the information sheet and the informed consent form. The findings were quite mixed. They had a pilot trial, or a run-in trial with 100 participants, and in that one, the intervention group drank more. In the main one, the intervention group drank less. And when that was combined, the intervention group seemed to drink a little bit less when signing the informed consent form. This is inconclusive. There were issues about different contextual factors between the pilot and the main one. So I think this study as a first hypothesis generating one is important, but it needs to be replicated so we can understand this better. Also, I think that because the framing was take part in a health survey, that might be quite different than if you ask them, would you like to take part in this intervention survey where you'll get support? Because you can imagine if you've been thinking about reducing your alcohol consumption, increasing your physical activity or whatnot, and then you get this informed consent sheet in front of you, you read through and you sign it, you physically sign it, or you check a box. Something goes on in your head saying, I've made this decision now. And if that step is not included in another group, then that might bias results. Anyway, some of you, I think this is useful still. Like, sure, this study in and of itself is inconclusive, but this information is useful. And I'll tell you why in the next to last slide in this talk, that the information about how people are shaped by signing consent forms is still useful, even though these effect sizes may be small. And I'm sure somebody out there is going, the null is in the confidence interval. I don't care. It's still going to be useful information. Right. So now we've gone through the phases of thinking about, why do I want to participate in this study? I've signed consent forms. And then we come to the step of saying, well, does the study design itself affect participants? So this was a cool trial where they asked participants to take part in a research project on student drinking. There was, I don't remember the numbers here, but these groups are quite large as I remember it. Students were invited to participate in a research project on student drinking. They were randomized to group A, B, and C. In group A, they were told that this is a cohort study. So we're just measuring your consumption now, and at a later date, we want to measure it again. So it's just sort of a longitudinal cohort study. We're following a group of students over time. In the control group, or B, group B, they were told that this is an intervention study. This is a trial. You've been randomized to receive the control. Another group of students have been randomized to receive the intervention. And then in group C, they were told, this is a randomized control trial. You've been allocated to the intervention group. There's another group that is in the control group that does not receive the novel intervention. But everybody got the same material. Everybody was told, and here is some material for you to look at. The intervention group were told that this is the intervention. The control group were not. But everybody got the same educational material on alcohol consumption. And then there was a 1 month follow-up to follow up consumption. Now, the effects on estimated alcohol consumption in this study were small, borderline non-existent, but still might be useful in other contexts to know about this. But what I found interesting was when you look at what these participants actually did. So 59% in group A in the cohort study actually accessed the material. So 60% accessed the material, and they looked at the educational material for 7 seconds on average. The control group, basically the same numbers, 57% accessed the materials, and they looked at the materials for 8 seconds. The intervention group, though, 78% looked at the materials and spent 35 seconds viewing it. So clearly, what we ask participants to do and what they believe is expected of them. So if you're in an intervention group and you say, here's the intervention, you're going to engage with that more because you're thinking, well, this is what is expected of me in this study. While the control group then didn't have that idea, and nor did the cohort. So how we frame the study and what we say to participants of what is expected of them is certainly going to affect what they do. Another interesting part, and this has shown up in other trials and studies as well, that both group B and C were no more likely than A to actually think that they participated in a trial. So a lot of the time when we interview participants after a trial, they're not actually aware of their condition or the trial allocation. They sort of get confused if they were in a trial or not. And because this was a finding, sort of an important finding of this study, this might also be why we didn't really see any difference in alcohol consumption, because there was a failure to sort of manipulate here. This also, I think, needs more investigating. We need to replicate this study in different settings and see how big a problem this actually is. I think it's interesting to see that you're asking participants in an intervention group the same thing as in a control group, but the intervention group know that they're expected to do something more than the control group and the cohort group. Okay, how are we doing on time? 35. Oh, plenty of time. Oceans of time. All right. So what to do? What do we do? All of this. I mean, I've only given you a small piece of the literature. This is not everything that is there. There's more. But what do we do? If we are now suddenly aware of this, if I provoked attention enough that you're worried about this now, and you're thinking, what should I do in my study? I think that most studies of behavioral interventions include all of these steps, and therefore some of these steps might be more important, or some of them may be less important when it comes to assessing the risk of bias. But what to do? Well, acknowledge the fact that they're there. I think that's step one. Acknowledge that we have a problem, right? So acknowledge that there are research participation effects and people are affected by it. Think from the participant perspective, I think is super useful. And that was also one of the things that was prominent in the systematic review of the Hawthorne effect and the later papers, that the idea when we are thinking about research participation effects, we should really put ourselves in the shoes of the research participant and think about what's going on in their life and how all of these things affect them. We can try to design the study to reduce the risk of bias. That's always good. We should always try to do that. That's nothing new. And as Consort says, then we should declare in the limitations potential sources of bias. I think this is good. It's a good first step, but it's not enough. I think we really should be doing more. We should be doing much more than this. Because usually when we're thinking, at least from my perspective then, public health, we're looking at interventions that are supposed to be delivered to a broad audience. We are expecting quite small effect sizes because we're doing something very brief, but which might be important when we look at it in a wider context and also when a lot of people engage with intervention. But then these research participation effects, while they are small, they might eat up all of your effect. I'll show you why later in a more structured causal model. But we need to think about these things and not just brush them under the rug. So therefore, all credit to Consort, and I think it's important to acknowledge this, we need to do more. So what I want to do, what I'm proposing that we do, and we start doing more routinely, is to account for research participation effects in analysis, and really all biases, but now this talk is focused on the research participation effects. So when I say account for them, I mean, I really want to get an estimate that is unbiased, an estimate of my intervention that has removed all of these biases. So I get a sort of clearer, more accurate view of the effect of my intervention with all of these other steps removed, all of these other biases and effects removed. That's what I mean when I say I want to account for them. And to do that, and to show you how this actually can be done, I'm going to take you through a trial that we did years ago, which I'm still very proud of, I have to say. I think this is a very cool study. And it concerns an electronic screening and brief intervention. You can see how old this study is because it says electronic. Nobody says electronic anymore. It's all digital and so on. Electronic screening and brief intervention. So electronic screening and brief intervention, in its essence, is that you ask a series of questions about alcohol consumption. Then you give feedback and advice for change based on these responses. And both of these components, both the questionnaire or the asking or assessment and the feedback, are believed to have an effect on alcohol consumption. This is widely used globally. It's also, the E here is electronic, but it's also been done face-to-face, just screening and brief intervention. Has a big movement, and the WHO recommends this type of interventions because they have a proven effect. But in a trial, when we're doing a trial and we want to test the effectiveness or the effect of an electronic screening and brief intervention, I'll just call them ESBIs, we usually want to screen participants into our trial. So we're going to have to ask them questions. We're going to have to ask them about their drinking in order to get the right population that we care about. Also, we usually want to assess behavior at baseline because we want to adjust our analyses. We want to, in our regression model, we want to adjust for covariates that has to do with baseline drinking. But we've known for a long time, and Richard Solomon was really the one that put this into context, that screening or any type of assessment changes behavior. So Richard Solomon proposed in 1949 that we should have control groups that are pre-tested as well in order to remove effects of pre-testing. So we know that assessment affects behavior. But we need to do the assessment because of the trial design. We need to screen people and we need to assess them to be able to do our analyses. But here we have a pre-randomization step which clearly overlaps the intervention component. So the intervention component is asking questions and the feedback. That's our intervention. But then we need to ask questions to everybody because we're in a trial. And then clearly a pre-randomization step overlaps what we're trying to do in the intervention. And what we would like to do is estimate the effect of an ESBI versus no intervention at all. That is no assessment and no feedback. That's sort of the true effect that we want to get at. And that's tricky in a trial, but I'll show you how it can be done. Okay, here's the study that I'm super proud about. And I think it's one of those studies which I'll never forget being part of because I think it's super interesting. Okay, this was alcohol assessment and feedback by email for university students, main findings from a randomized control trial. The idea was that we randomized students at universities in Sweden. We got their email addresses, we randomized them, and we sent them an email. Nobody in this study were told that they were part of a trial. So there was deception in the sense that they were not part, we didn't tell them that they were part of a research project. We didn't tell them that they were part of a trial or anything like that. One group got a link to assessment and feedback. So they got the full ESBI. That's the assessment and feedback group. There were about 5,000 participants in that group. The other, one group got assessment only. They didn't get any feedback. They just got the assessments. And one group we didn't contact at all. They didn't get an email at all. We just had them randomized and stored for later purposes. And then 3 months later, we sent everybody, all of these participants, all of these students, we sent an email about a survey on lifestyle behavior. We didn't make any reference to, oh, by the way, this has something to do with the alcohol survey you responded to 3 months ago. We didn't make any reference. We did everything that we could to separate these two things from participants' minds because we did not want to have any effects of being part of a study or anything like that. We wanted to remove all of that. And in this lifestyle behavior survey, we had a couple of questions about alcohol, but the survey was about lifestyle in general, so that there wasn't a connection made. Aha, they're asking about alcohol again. This has to do with the survey I did 3 months ago. And now everybody was included, including this no contact group that we hadn't contacted at baseline. Okay, this allows us for some interesting analyses, and let's look at what happened. Okay. When we compared assessment and feedback versus assessment only, we saw basically no difference. The assessment and feedback group had 0.4% higher audit C scores in the assessment and feedback versus assessment only. Okay, basically nothing going on. And it would have been a normal trial. This would have been a normal trial of an ESBI where you would have had everybody was screened and then you had assessment and feedback. So this is very typical. And we might have said, well, there was no marked effect of ESBIs. There doesn't seem to be any effectiveness here. And in our limitations, we might have said something along the lines of, well, assessment may have biased our findings, but we don't believe assessment to have such a big effect that they would have sort of changed our decision about the findings here or our conclusions. And that would have been quite normal procedure. But we would have been wrong. We would have drawn the wrong conclusion. Because let me show you what happens when we compare the assessment group versus no contact. Here, you have a large effect. Here we're looking at 3.5% higher audit C scores in the no contact group. So the assessment alone had an effect on audit C scores. So considering that very few ESB trials considered this bias, there's a lot of trials of ESBIs out there that have made the wrong conclusion, and probably you made decisions not to disseminate the ESBI when you should have. Also, what was interesting was when we look at assessment and feedback versus the no contact, there wasn't much difference. So feedback on top of assessment doesn't seem to have a lot of effect. They very much overlap each other. We can't really say what the effect of feedback alone is because this trial doesn't allow for that. We should have had a fourth arm for that to identify feedback only without assessments. So we don't know if they completely overlap or if assessment alone is effective and feedback has no effect at all. And that needs to be studied further. But as we can see here, clearly a pre-randomization activity, screening and assessment, overlaps our intervention, and severely so, a lot, right? But it is not a good idea to use deception routinely in science. We should avoid deception at all costs, and only when it's very valuable to learn about some phenomena that is understudied should we even consider using deception. So this is not a routine sort of way of setting up a trial. We shouldn't be doing this all the time. But then you go, well, okay, if we can't do that, how are we going to get to this conclusion then? How are we going to be able to remove this bias of pre-assessment if we can't use deception? Well, I have an idea. I have an idea, and it's using causal models and external data so we can account for assessment, even though we don't have a no contact group in our trial. And there's a preprint out which has the incorrect title. So that's why I've changed the title in this copy in here. It's called Causal Models Accounted for Research Participation Effects when Estimating Effects in a Behavior Intervention Trial. So the preprint accidentally went out with the wrong title because there's only one trial involved in this paper. There's not multiple, and this says plural. Anyway, also, I'm talking about assessment effects now, but the models I'm going to propose here can be used for any type of bias, and not only research participation effects, but really any type of bias that we are aware of. So these models help us account for them in analysis, not only just acknowledge them and mention them as limitations, but also account for them. Okay, if you're not familiar with causal models, don't worry. I'll just sort of explain this without going in too much detail about causal models. But the idea is here that I'm making a theory, and my theory is that feedback has a causal influence on alcohol, the outcome. Okay, so that's it. This is a normal randomized controlled trial. I have something here. I test the effectiveness of that on the outcome. I can estimate the total effect of feedback versus no feedback. And that's basically what we did in this Amadeus trial, when we looked at assessment versus feedback and assessment. So that's a standard trial of an ESBI. That's hopefully non-problematic. I can go further and say, well, I believe that feedback has a causal influence on alcohol, but also through some mediator, for instance, reflection. So when we're designing ESBIs, we think a lot about, well, what kind of mechanisms or mediators are we trying to trigger in individuals? And part of that is reflection. Think about your drinking is something that is prominent in the literature. That's something that we try to do. So it's not unreasonable for me to say that I believe that feedback has a causal effect on alcohol consumption. And part of that effect is mediated through reflection. Not all of it. So there's some effect that isn't mediated through reflection, but some of it goes through reflection. This is non-controversial in the sense that I can now estimate the direct effect here. I can estimate the indirect effect, but it's still feedback versus no feedback. So assessment still plays a role here. I haven't considered assessment yet. I've just broken it down to an indirect and a direct effect. There's nothing new going on. It's still the total effect we're measuring, and it's still assessment and feedback versus assessment. So the results are the same. But here comes the trick. What if I also suggested in my theory that assessment affects reflection? It's reasonable to think that once you start answering questions about alcohol consumption, there's a process of reflection that goes on in your head. You start thinking about your alcohol consumption in a way so that you can respond to the questions. You might start thinking about, maybe this isn't a great idea. Maybe I should start changing my alcohol behavior. So I hypothesize here that assessment affects the mediator, which in this case is reflection. What I can do now, and I won't go into the details are in the paper, but I can actually estimate the total effect of feedback and assessment versus no feedback and no assessment. So given that I've set up this theory and I've done some assumptions about how I believe the causal model looks, I can now get to this feedback and assessment versus no feedback and no assessment. It will require some assumptions about how much assessment affects the outcome. We know that. We could use data from a previous study. In this case, we actually have data on it in the Amadeus study. But if you don't, you could always use a mean and a confidence interval that you find in another paper. You could use that as a basis for assuming how much assessment actually affects the outcome. And in this case, you don't have to do the dubious sort of no contact group, and you don't have to use deception. And when we did this, we found that we were able to get back our estimate. So we were able to use this model to actually estimate the effect of assessment and feedback versus no assessment and no feedback. And we got the same result as when comparing group 1 and group 3 in the Amadeus study. So there's sort of some sanity check that this could work. And this is useful. I mean, if you're sitting on data right now and you're thinking, maybe there was some pre-assessment or pre-randomization activity that we were doing that affected our outcome, then maybe we should look back and see if we can make an adjusted analysis where we account for that bias. And interesting stuff, I'm sure, will happen. Our normal conclusion would have been that the ESBI didn't have any marked effect on alcohol consumption. But in this case, we see, well, there seems to be something going on, and maybe it's worth pursuing further a bigger dissemination of these interventions. So if you didn't get any of that, if that was sort of didn't make sense to you, then maybe just taking this sort of quote with you, that using a causal model and assumptions about research participation effects, you can estimate unbiased effects. And it will be Bayesian. Like, of course, we're going to use Bayesian inference to do this because it sits nicely with the way Bayesians think about uncertainty. And it sits nicely with incorporating all the uncertainties that you have into one model. Please come talk to me if you believe that this has happened in your studies, and we could look at what we could do about it. Let's see, 52, great. I think this is my last slide, or next to last slide. We don't need to stop there, by the way. We don't need to stop at assessment only. So I had some evidence earlier that signing informed consent forms affects decision to make change. So why wouldn't I want to model that? The feedback now affects reflection, this mediator here, which affects the outcome. Feedback, I've decided, also reflects the decision to make a change, which affects the outcome. But signing the informed consent sheet also affects the decision, which affects the outcome. The possibilities are endless, right? You could just add on all the biases that you think are there, and then you make assumptions about the sizes of those biases. So in this case, we have a measurement of this 0.29 difference audit scores that we could actually use in our model here. So a previous study has estimated this. We use that uncertainty about that effect, incorporated in our model to try to unbias our estimates in our study. And this is why I don't care about that the confidence interval contains the null. That doesn't matter to me at all. I care about the distribution that was estimated, because I want to use that as an uncertainty in my causal model. Okay. So again, this is a little bit, if you're not used to thinking in causal models, this might be a little bit hard to grasp, but just think about the fact that we can use previous studies which have estimated the magnitude of biases and magnitude of these research participation effects, and actually use that to account for research participation effects in our studies. This, I think, is super interesting, and I think there's a lot that we can learn and discover about research participation effects. We might get better unbiased effect estimates of our interventions, particularly behavioral ones, as they're known to be susceptible. And then there's always somebody that says, well, this is going to require assumptions. Yes, it will require assumptions. All fun things in life do. However, I would say if you assume that there's no research participation effects in your study, that's a very, very strong and incorrect assumption. I would say it's more likely that there are research participation effects than there are not. So assuming that they don't exist at all is a very strong and incorrect assumption. That's it for me. Thank you for listening. Emmy asked me also to mention that our next mobile seminar is on the 7th of May, and it's Ulrika Müssner who is giving the presentation on digital encounters. Email Emmy to register. Thank you.